There are probably few things in watch repair that are more frustrating than using one of these blue puck, inexpensive demagnetizers for the first time. You probably got one because someone has either told you that your watch has been magnetized, which is why it's running fast, or maybe you've just learned that demagnetizing should be part of your regular watch service. If you're using a professional grade demagnetizer, it's a no brainer. You put the movement on the top, you press the button, and boom, your watch is demagnetized. Well, that unfortunately is not the case for these little blue pucks. But if we're going to be honest about it, if you're new to watchmaking, you may not be ready to invest a lot of money into a demagnetizer yet. Now, when you look at one of the professional grade demagnetizers and this little blue puck, what you're really paying for is the difference in the convenience of one over the other. The professional machines, you just push the button and it works. You don't really have to verify anything because it's that reliable. With this, it still works, but you need to check as you move along to make sure that it's actually demagnetizing and how much it's demagnetized. Now, physically, magnetization is caused when groups of atoms, which are called magnetic domains, all line up in one direction after they've been exposed to a magnetic field. To demagnetize something, that requires the randomization or scrambling of these domains so that they're not all facing in the same direction, right? They need to be scrambled up. So think of a football stadium full of fans, okay? If each row in the stadium represented a atom domain or a group of fans, okay? When they're all facing in the same direction, that stadium would be magnetized. Now, picture a football stadium full of fans, and they're all facing in random or different directions. In that case, the stadium would not be magnetized. Now, most people have also heard that you can test for magnetization just by using a compass. And although a compass will obviously detect magnetism, it can also kind of give you a false positive reading, especially if you're not understanding what's going on. Almost all ferrous metal containing nickel or iron has some low level of magnetization. In most cases, it's not going to appear as it's magnetized, and it's not going to be strong enough to be attracted to another piece of metal. Now, plain steel, even if it's not magnetized, can act like a temporary magnet when the compass needle is near it. The needle swings, and you think, oh, it must be magnetized, but it's just the compass creating that pull to the steel. All right, so here's a steel rod. And you can see that when I try to pick up this tiny little screw, it doesn't appear to be magnetized, right? But when we move it close to the compass, you see the needle react slightly and it's moving. The magnet in the compass needle is picking up a very mild magnetic field. When you bring the compass close to something that is truly magnetized, the needle's actually going to align itself with all those domain groups that we just talked about. So this test works well enough for most people. Now, when I test for magnetism, I don't want to just know that it's magnetized. I want to know how much magnetism is actually present. What I like to use is this app called Magnetized Wristwatch. And this works with the iPhone's magnetometer to measure magnetism. Now, the magnetometer is what the iPhone uses for its compass feature, okay? And it's very simple to use. So you start by sitting the phone down and calibrating it. Now, this calibration basically accounts for all the natural magnetic fields around you at that one moment. So once you calibrate it, you don't want to move it. Then you need to find the magnetometer in your phone. And you do that by holding a metal object over the screen, moving it around to the point where you get the highest reading, and then you double tap on that spot. That is where the magnetometer is. And since that is where the magnetometer is in your particular phone, that's where you take your object that you're checking, leaving it about a half inch over the screen, and it will read the level of magnetism present. Now, if it's showing green, that's not considered to be magnetized at any point that actually matters. If it's in the brown area, well, that's a positive test. And if you get all the way up to this red line, I would say get your item away from the phone because that's going to damage something. Now, the way this demagnetizer works is when you press the button, it creates a magnetic field, and that field flips between the north and south poles 60 times per second. And that's represented in this image by these alternating arrows, okay? And then that magnetic field continues up until it actually fades away and shrinks to zero. Now, if you leave metal in this area right here, or if the magnetic field is interrupted while your object is in this area, it's either going to become magnetized or it's going to remain magnetized. And this is a problem that I know a lot of people have who don't know how to use it. They think that they have a magnetized watch, and then they use this blue puck, and what ends up happening is if you don't use it right, you actually magnetize the watch that wasn't even magnetized before. Now, the pro units, they do this fade out for you. You don't have to move anything. You just press the button. They fire off a very fast fading magnetic field, and they shut off. No technique required. And this all happens in like a tenth of a second. In the blue box, you make the fade out by moving the watch out of the magnetic field. Now, it can work perfectly, but only if you do the move through the field in the right amount of time, in the right direction before you release the button. Okay, so let me show you how to do it the right way. I'm going to start by magnetizing this movement. I'm going to check the level of magnetism so we can actually see the reduction as we use this little blue puck. Looking at the hairspring on this movement, you can visually see the coils of the hairspring being attracted to each other. It's these coils sticking together or touching as the hairspring vibrates that shortens the effective length of the hairspring, and it makes the rate go up. So to do this properly, we're going to start with the movement over the coil of the blue box. We need to press and hold the red button no more than 5 seconds, or it's going to overheat the coil and break the magnetic field. If you break the magnetic field, it's going to either magnetize or not demagnetize whatever it is you're working on. We're going to slowly withdraw in a smooth motion, lifting straight up. And we need to lift it up between 8 and 10 inches within 2 seconds while holding the button the entire time. Then, after that initial 10 inches, we're going to continue to lift up, and that guarantees that the magnetic field has completely faded away. Now we need to check our work. If there's still magnetism present, which there could be, you have to wait at least 1 minute for the coil to cool down before attempting to do it again. If you don't, when you press the red button and try to demagnetize it, it's not going to do anything. And then you're going to wonder why it's not working. All right, so here I am. We're going to do it again. And now when we check it, you can see that the magnetism lowered a little bit more. Depending on how magnetized something is, the blue box only produces a small magnetic field compared to other machines. So oftentimes you may need to do it more than once. Because this blue box is limited in the magnetic field that it can produce. What happens when you do it the first time is it removes some of the magnetism that's present. So you have to do it again, and you keep scrambling all these domains that are causing the magnetism, and you kind of chip away at it until you get down to a level where magnetism isn't detected anymore. But again, one of the problems that happens is they do it right the first time, they don't do it right the second time, they do it right again, they do it right again, then they do it wrong, and there's no consistency. So it doesn't appear that the puck is working correctly. Now, what happens if you do it wrong? Well, here I'm going to let go of the red button early, okay, while it's still in the magnetic field. Now, because the movement was still in that alternating field, the movement is now magnetized again. And that's what I was just talking about. Now, for sure, the most common mistakes made when using this blue puck is releasing the button while the movement is still in this magnetic range, jerking the movement sideways instead of straight up and away, keeping the watch on the pad too long before actually moving up, and not letting the unit cool down before using it again. Remember, it's like 1 minute is what you need. So listen, get one of the blue pucks and start by practicing with something that really doesn't matter, like a screwdriver and a paper clip. Then demagnetize it until the screwdriver won't pick up the paper clip anymore. Once you can do that, now you're ready to start working on any type of magnetized watch that might land on your bench. And because there's so much more to learn, I hope to see you in the next video.